today's lesson, our last quick review, we are doing quick review number 4. For today's objective, we are going to be reviewing solving basic quadratic equations. Our language objective is to explain the process we take when solving equations. So let's take a look at today's thinking. Welcome to today's quick review. Today's thinking question is, how do we solve quadratic equations? So solving a quadratic equation. When asked to solve a trinomial, we will need to make sure we factor the trinomial completely. Once our equation is factored completely, we can apply the zero product property. What is that property? We can separate each and set it equal to 0, which means that each of those factors are going to be equal to 0 or set equal to 0. So let us refresh our minds on these types of equations. Let's look at example 1. For example 1, what we are going to be doing is factoring expressions completely. So when they ask us to factor something completely, an expression completely, we want to go through the process of greatest common factor, trinomial factoring. We could have difference of two perfect squares. We could have a nice little combo of stuff. So let's look at number 1 and see what exactly we have here. The first thing I'm going to identify is there a GCF? In this case, yes, my GCF is X. They both share the X. When you identify that GCF, what you have to do, or what you should be doing, is dividing each of those by that GCF. So you would take that GCF out and you would be left with x squared minus 16. Now I am not done. That's why we're factoring completely. I'm looking inside the parentheses and I'm going to see if I can keep going. What type of factoring do I have now? This is a factoring of two perfect squares. So we have x, our original GCF, times x minus 4 times x plus 4. And now I am officially done factoring. Let's look at number 2. Same kind of process. I want to first identify, if possible, a GCF. Do I have a common factor? But let me slow myself down. Before I do that, let me just rewrite this in standard form. So let's put the x term first, followed by the x, followed by the constant, just so I have it in standard form. So now looking at that, is there a GCF? Clearly we can see it. The GCF is 9. So what am I doing with that 9? I'm dividing each and every term by 9, taking that GCF out. I'm left with x squared plus 2x plus 1. Now I have a trinomial. Can I factor that trinomial? In this case, what I'm looking for is two numbers that are going to add and multiply to the last. So we have the values x plus 1, x plus 1. And the last one, we are going to identify that GCF. We don't need to rewrite this in standard form, which is good. So here we have an x for my GCF. I am going to divide every single thing by the x, by that GCF. And in this case, I am going to look at my trinomial and see if I can keep going. Now, for this type of problem, I do something known as the AC method when it comes to factoring. So AC method to me is pretty simple, so I tend to do that. What you have to do is you're going to multiply the A term with the C term, and you're going to create a brand new trinomial that's a lot easier to factor. When I do that, what I'm going to start off by doing is dropping down that x squared, dropping down the 2x, and my last term is now going to be my AC piece. What does that mean? That means whatever I get from multiplying the 3 with this negative 5. So in this case, negative 15. So I'm creating a brand new trinomial, so it's just easier for me to factor. Now that I have that, I know the factors to that. Now we do have to remember that my original trinomial was not this pretty one. It was this more complex one. So at this point, you're going to bring back the a piece. So you first multiply the a times c, get new trinomial, factor it, and now divide the numbers by the a. So what's our a? I'm dividing the numbers by the a, which is 3. Now here, you see that we have -5/3. Can I simplify that any further? No, this is in its most simplest form. So what you're going to do, because we never write our factors in this manner, we're going to bring this denominator in front. Here we have 3 divided by 3, and that we can keep going or can simplify to give us a value of 1. So the factors of the 3x squared minus 2x minus 5 are 3x minus 5 times x plus 1. And don't forget that we had our original GCF. That GCF has to be brought down as well. So this is AC method of factoring. You will see me do this a lot when it comes to factoring. So let's take a look at example 2, and in example 2 we are going to actually be solving these quadratic equations. For number 1, it says show all your work to solve the equation 3x squared minus 75 equals 0. So first thing we're going to do is identify if there's a GCF. Divide each piece by 3. Take that GCF out. I am going to keep going and factor that. And at this point, I am going to use the zero product property, which tells me that I can split up everything and set each factor equal to 0. So I'm going to start with this 3. 3 equals 0. We know that is not true, so I am going to say 3 does not equal to 0. I have x plus 5 equals 0, which means x is equal to -5. And I have x minus 5 equals 0, which means x is equal to +5. So my answers here are x is equal to -5 and x is equal to +5. For number 2, we are going to start off by setting our equation equal to 0. So I'm going to move my like terms to the left. Now that I have it set equal to 0, I'm going to go ahead and factor this. Look for that GCF. Divide every single piece by that GCF. Factor that trinomial. And I am going to use my zero product property to split this up. Set each equal to 0. So our answer here is, or are, -8 and -1. For the last one, let's start off the same way, moving all our like terms over and factor. So I'm going to make you guys pause the video and get to that point, setting everything equal to 0. What you should be doing is AC method. So try to do the AC method and let's see if we get the same factors. All right, so if I do this AC method, this is where I should have gotten. I am going to bring back the A term by dividing each by that and simplifying this. So I simplified my fractions, and now that I have it in its most simplest form, I am going to take those denominators and bring it to the front of x. Okay, so now that I have that, I am going to go ahead and set each equal to 0. And we get x is equal to -1/2 and x is equal to -8/3. So I will see you in our next official lesson.